Hello, in this video we will go over how to take the solid of revolution, or also known as volume, by using the disk method. So this is calculus 2, and we are learning disk method. So we will taking a 2D dimensional shape and turn it into a 3D dimensional shape by either evolving around the horizontal axis or vertical axis. We will create a solid revolution using disk method. We will take a bounded region that is flushed against the horizontal or vertical axis, and we will spin it around those axes to create a three-dimensional solid. So the solid of revolution, also known as disk method. So your goal is to take a 2D region, revolve it about a horizontal or vertical line to, and somehow you're supposed to create a disk. So take a typical 2D region and you either revolve it around the vertical or horizontal line, and the slice should be perpendicular to the axis of rotation. So here's it. It'll say what rotation. Sometimes they'll say x rotate on the x-axis or rotate on the y-axis. They'll say, um, and yeah. So you somehow create a rectangle, and then we know that the rectangle you have a width and the radius, right? So the shaded region is the entire flush against the axis of the rotation. So just make sure your slice is perpendicular to the axis of rotation. So in geometry, we have learned that the volume is equal to the area of the disk times the width of the disk. So it could also be expressed as pi times r squared times w. It can also be expressed as pi times r squared times a delta x. In calculus, we have volume equals limit as n approaches infinity of the integral, from the summation from n to infinity of p r I squared times delta xi. And you have the disk formula, which is volume equals pi, because pi is a constant, you can take it out, from r to r of r squared dy. So instead of popping things out of the board, instead we're going to go try to think of it as we are going to revolve. So yeah, so if you look at this example, here you are, right? Here's the axis. Let's say you had this looks like a quarter of a circle, and this is the axis of symmetry right here, right? And then you have this little rectangle, and here you are standing. So sometimes they'll say rotate across the x-axis, y-axis. So it's good to know where you're standing, because at least now you'll see why when we have to put our boundaries. And then this is the height, r equals height. And this is the width, which is also known as the delta x. And then we have what's called the horizontal axis of rotation. So the horizontal axis of rotation is volume equals pi from the integrals a to b. So look at your integrals, a to b of r squared times d of x. In order to use a to b, it is spanned along the axis of rotation. These formulas, two things must happen. Slice must be perpendicular to the axis of rotation, and then the shaded region is entirely flush against the axis of rotation. Okay, so this will all make sense when we do a problem. And then you have the vertical axis. So when you have a vertical axis, your boundary is from C to D, from r squared dy. So basically, it means top minus bottom function. So what we want to do is think of the bigger picture. You could think of it as a cylinder, right? Here we have a cylinder, and we know that the area of a cylinder is pi r squared, and we know that the volume of cylinder is pi r squared times h. So let's do an example because this all doesn't make sense if we don't do an example. So example one says find the volume of the solid formed by revolving the bounded region about the axis of revolution, and we are given y equals radical x, y equals 0, x equals 0, x equals 4, about the x-axis. Okay, so what we have to do is kind of draw your image. We know how y equals radical x it's a square root graph. We know how y equals 0. I believe that is a horizontal line. X equals 0 is a vertical line. X equals 4 is also a vertical line, right? So if you kind of drew it, here's 0, is 4, and then y equals radical x would look something like this. And then x equals 4 would look like this, would go like this. And what else do we know? So yeah, we need, okay, yeah, so this y equals 4 is like this, and then x equals 0 is like this. So what we need is these points. We need to find this point. I think that's easy, that's 0, 0. And we need to find this point. Because we need to know those points so we could find the boundaries. So if we have y equals radical 4, I mean radical x, and then we plug in the x value 4, that's square root of 4, which is 2, right? So we have a point here now at 4, 2. Okay, so let's draw our image. So let's see what they're saying. It says find the volume of the solid formed by revolving the bounded region about the axis of revolution about the x-axis. So where's the x-axis is right here. And what is the rule when it's bounded across the x-axis? Horizontal axis, right? Wait, yeah. X is the horizontal, y is the, yes, horizontal would be considered the x. So we're going from the boundaries a to b of r square. And no, horizontal is not. It's actually the vertical, right? Vertical means we have to go from boundaries from C to D, and we're going from top function to minus bottom function. So we're going to use this formula because it's specifically rotated across the x-axis, which is technically the vertical axis, right? So we can start setting it up. So it's vertical, so it's going to be the integral from pi from a to b of r squared dx. So really that's the same thing as pi from the integrals a to b from top minus bottom square of dy. So it's going to be volume equals pi, and then from the integral. So what is our a to b? So we're going across about the x-axis. So if we're going from top to bottom, I think, yeah, vertical. So this is your vertical axis, right? The y. So I think we're going to go from this point, from 0 to 4. So our a is 0. and my b is 4, right? And then top, if you look at our image, what is our top? So if you want to draw, if we're going across the vertical axis, that means we're standing upright, like this, right? If you're going across the vertical axis, you're standing upright. That means your head is the top, and then your feet is the bottom, right? So what is your head touching? The radical x. So it's going to be radical x minus the bottom. What's our bottom line? This horizontal line, y equals 0. Square and then dx. So it's going to be volume equals pi from 0 to 4. And then what's a radical to radical x minus 0? It's just radical x. And then if you square that, that's x dx. And what is the integral of x? It is 1/2 x squared, right? And then we can plug in our boundaries, 0 to 4. And then don't forget you took out this pi. So I'll put the pi at the very end. So it's going to be 1/2 4 squared minus 1/2 of 0 squared. Okay. So 4 squared is 16 over 2 minus 0. And then you still have this pi. So that would be 8 pi. Okay. So let's a little recap. It says it's revolved about the x-axis. So that means we're going vertical. So that means we're going from A to B or top to bottom, because vertical is top to bottom, right? I think horizontal would be right to left. And then our lower boundary is from 0 and our upper boundary is from 4. And our top function, so what is our head feet touching? The radical x. And then our feet is touching y equals 0. Okay, pretty yeah, was an easy one. So let's move on to example 2. Example 2 says, find the volume of the solid formed by revolving the bounded region about the axis of rotation. We have y equals square root of sine of x equals 0, x equals pi about the x-axis, and where y equals 0. Okay, so what we're going to do is draw our image. So it says about the x-axis, so that means we're going vertical, right? We're going vertical here. Let me show here. Let me show you image. So let's graph our graph. So y equals sine of x. We know that y equals sine of x, or y equals square root of sine of x would look something like this. And if we're revolving, here's the x-axis, right? We're revolving around the x-axis. And that means we're going top to bottom. So so this graph here is y equals sine of x, and then we're going vertical. So we're revolving across the x-axis, so we're going vertical, right? And if you draw your image, if you draw you, vertical, your head is the top, your feet is the bottom. And then our boundaries is, so we're going to use this, but v equals pi from the integrals a to b of r square dx. And then we're going from top to bottom. Top minus bottom squared dx. It's going to be v equals pi. And then what's our a and b? I think our lower boundary is 0, right? So we're going vertical. So our lower in terms of y, so it's going to be, this is facing 0. And then what is this y value? I think it would be pi. Yeah. Yes. From 0 to pi. Yes. So our upper boundary is pi. And then our top is the square root of sine of x minus the bottom, which is 0, square dx. And then when you square this, what's the square root of sine of x? That's sine of x d of x. Okay. And what's the integral of sine of x? It is negative cosine of x. And we're going from 0 to pi. And don't forget, we did factor out a pi, so that is going to be pi, and then it's negative cosine pi minus a minus cosine 0. Okay. Cosine of pi is -1. And then you have an extra minus. Over here, we have 2 positive. The cosine of 0 is 1. A negative times negative is positive, so 1 plus 1 is 2. So your volume is 2 pi. So if you kind of look at the bigger picture, right? It's revolved across the x-axis. So here's the x-axis, right? And we're making small discs, like this. So if we're to add up all those disks from 0 to pi, we should get a total volume of 2 pi. Okay, well, let's move on to example 3. So example 3 says we have y equals x squared minus 4x plus 5, where x equals 1 and x equals 4, and y equals 0, revolving about the x-axis. So if you're revolving around the x-axis, you're going top to bottom, right? Yeah.
You send it already?
Yeah.
How come you send it already? Please do it today so I can file an attention. Are you sending that wrong?
Yes, I sent it via email.
Huh?
Mom, I'm working.